Greetings to all the viewers of the channel. Inverters have piqued the interest of many, and today, fulfilling the request of the viewers, we will review a cheap but very good converter. From 12 to 220 volts. Initially, it was planned that today's test would be done by the little one, but he got a bit carried away, so I will continue for him. By the way, you can see more detailed tests of this converter in the article, and the link to the article, as always, is in the description. I want to note that I have been buying products from China for many years, and this inverter is one of the best purchases, and now I will explain why. But first, let's examine the main parameters of this little device as stated by the manufacturer. In short, you just need to plug the inverter into the cigarette lighter, and you get 220 volts at the output. From this voltage, we can power small network loads with a power of up to 75 watts. There are two versions of these inverters, one for 75 watts and one for 150 watts. In the description, you will find a link to both versions. During the tests, we will open it up, examine the internals, and check all the main parameters to determine if it's worth the money. By the way, the price is less than $10, which is already a big plus. First, let's connect the inverter to a 12-volt power source and check the output voltage. It should be within 220 volts plus or minus 10%. By the way, the inverter has a soft start function, so it turns on with a slight delay. As we can see, the output voltage is normal, and the no-load current is 150 milliamperes. Let's move on. Test. Number 2. Output frequency and waveform. I remind you that the output is a modified sine wave, and the frequency should be around 50 Hz. The multimeter displays the frequency of the output signal, and as we can see, everything is within the normal range. Now let's look at the waveform of the output signal. Since my oscilloscope is rated for 80 in signals, and here we have as much as 220, I will use a step-down transformer. I could use a divider, but the transformer was lying nearby. On the oscilloscope screen, we observe a modified sine wave. Everything is normal here as well. Let's move on. The inverter has several protections, in addition to the input fuse that is installed on the board. Protection against low voltage. The inverter shuts off if the battery voltage is below critical. To test this protection, a small incandescent lamp is connected to the inverter's output. Power of 12 volts is supplied to the input, and the inverter starts working, as indicated by the lamp lighting up at the output. Now we simulate the battery discharge by lowering the voltage on the power supply. And, as we can see, at a voltage of about volts, the lamp turned off, and the inverter went into protection mode. Such protection is necessary because, at low supply voltage, the control circuit will incorrectly manage the power switches, which may result in them not closing completely, or one of the switches may not close at all. By that time, the second one will already be open, and both switches, or one of them, may fail. Now let's open up the inverter to understand all the ongoing processes and also assess the quality of the soldering and the board as a whole. We see a small printed circuit board on which the main working components are located, specifically, 2K7500 type generator chips. Essentially, this is a push-pull PWM controller and is a complete analog of the TL494. One of the chips is the initial generator and controls the field effect transistors of the low voltage circuit. These, in turn, drive the pulse transformer. The circuit is implemented using the push-pull topology, a push-pull configuration with a center-tap transformer, where the positive from the power source is connected. The output of the control PWM controller is supplemented with low-power switches for the rapid discharge of the gate capacitance of the field effect transistors. This is the waveform on the gate of one of the transistors, with a duty cycle of 63% and a frequency of 40 kHz. Thus, the transistors control the pulse transformer, at the output of which we obtain high-frequency alternating voltage, which is rectified into DC and smoothed by an electrolytic capacitor. The voltage on this capacitor is about 300 volts. Then this voltage is applied to a bridge amplifier built on 4 N-channel field effect transistors. The switches here are IRF 730. In this part, each pair of transistors operates at a frequency of 50 Hz, and the frequency is set by the second oscillator, built on the K7500. This is exactly how the output frequency of 50 Hz, modified by a sine wave, is formed. I hope I explained the operation quite thoroughly. If you have any questions left, feel free to write them in the comments. By the way, the converter also has a USB output at 5 volts. But schematically, the 5 volts come from a linear regulator, so the current is small. You can charge basic phones, in principle. It might handle smartphones, but I advise against it, as the linear regulator will heat up significantly. Now let's reassemble the inverter and return to testing to check the maximum output power. I remind you that the manufacturer claims a nominal 75 watts and a maximum of 100 watts. The red multimeter shows the current consumption at the output, the green one shows the output voltage under load, and the wattmeter displays the input voltage. Result. In the end, the power consumed from the power source is 124 watts, and we get 107 watts at the output. Efficiency. Guess for yourself and write in the comments. Now let's check the short circuit protection at the output. And, as we can see, everything works perfectly, the protection reacts instantly. I must note that there is no reverse polarity protection for the input power, but it's not needed here, considering that the inverter is designed to work from a cigarette lighter. It's virtually impossible to mix up the polarity, even if you really wanted to. You can connect almost anything to this inverter, except for asynchronous motors and network transformers. Although the latter will also work, they will just heat up a bit and make a peculiar sound due to the pulse shape. Conclusion. I personally recommend it. A great investment. And I believe that such an inverter should be in the glove compartment of every car. It's cheap, doesn't take up much space, works reliably, and can power anything. Friends, as I already mentioned, you will find links to such 75 and 150 watt inverters in the description. There is also a link to a very detailed article with tests. Don't forget to share this video with friends and give it a thumbs up if you liked it. And I have to say goodbye for a little while until we meet again. Bye.